So in this video, we're going to take a look at tape diagrams, and I am in Accelerated 7, Unit 3, Lesson 2, and I'm going to use the Part 2 of that lesson, Every Picture Tells a Story. So tape diagrams are something that students will use throughout this unit that will really help them with visualizing how to solve equations. So the first problem says that Maya made 50 flyers for 5 volunteers in her club to hang up around the school. She gave 5 flyers to the first volunteer, 18 flyers to the second volunteer, and then divided the remaining flyers among 3 remaining volunteers. So the 5 here would represent our first volunteer, the 18 would represent our second volunteer, and the 3 X's are our 3 unknowns. Now what's really nice about tape diagrams is that you can see the size representation. 5 is small, 18 is larger, and my X's are all the same size. That's the whole concept, is to help students understand the relationship of the numbers. So we know that these 3 numbers, these 3 X's, have to be smaller than 18 because our 18 bar is taking up a large space. And we know the total is 50. So for families, so they can see what this equation is, this is actually 5 plus 18 plus 3 X's. Now, as we go through solving equations, we help students translate these tape diagrams into numerical representation. And the total, or equal, is 50. Okay, now some students may like to put these like in 3 X's because that's exactly what it is, but we help students understand they can combine these, and they can also combine the 5 and the 18. So if they handed out 5 flyers and another 18 flyers, then that would be a total of 23 flyers. So when we simplify, and we teach this to the students throughout the lesson, if we simplify this, we have 23 plus 3x equals 50. And this is a very standard equation. But we have students use the tape diagrams because they can visualize it. So what students will do then is they'll say, well, if they gave away 5 and they gave away 18, then they'll subtract, because that's how many flyers were distributed, 23 already, and that would leave them with a leftover of 27. So then they would rewrite or maybe redraw the tape diagram to represent 3 somethings equals 27. And at this point, because of their multiplication strategies, they would know 3 times something equals 27, and my unknown would be 9. Now, what we would have them do is go back into the tape diagram and just double check their math. We start it with 5, 18, and then each flyer of the remaining students got 9 flyers each. So we would have them go back, plug that in, and then re-add everything just to make sure that they have a total of 50 flyers. So we're solving the equation, but without using the standard algorithm, because if we can visualize it in the form of a tape diagram, it would help the students make more sense of the problem. All right, so let's take a look at the second question. To thank her 5 volunteers, Mia gave each of them some stickers, the same number of stickers, but then she gave them each 2 more. So altogether, she gave out 30 tickets. So the tape diagram represents each individual volunteer. So volunteer 1, volunteer 2, 3, 4, and 5. And each of the volunteers received some number of stickers plus 2 more. And they all received the same amount. And the tape diagram does a nice job because it shows the size, that they're all equal. So the equal amount for each volunteer. So what we help students do is represent this as an equation as we walk through these tape diagrams. And what we have here is we have 5 volunteers who each received some number of stickers plus 2. So this would be kind of like verbalizing 5 groups of y plus 2. And the total is 30. So we may have them use the distributive property to write this using parentheses. 5 groups of y plus 2. Now, some students may recognize that we can rewrite this by grouping the y's together and the 2's together. So they may say, oh, well, we can rewrite this to represent 5y's, or y plus y, and some students may benefit from physically writing out y plus y plus y plus y plus y plus the 2's, okay? And again, 2 plus 2 plus 2 plus 2 plus 2, and it totals 10. And again, some students may benefit from writing out the 2's. They may resketch this or do a quick redraw, and I'm going to do a real quick one here. And they may say, okay, well, I have my y's, so they're going to set up their 1, 2, 3, 4, 5 y's. And then I know she gave 10 more tickets, and altogether that was 30. So at this point, they have two representations of the same equation. And this is something that we help them and work through and walk through as we teach this lesson. So the students may say, well, if I take this 10, she gave out 10 additional stickers, I can take 10 away from 30, and that means 20 is what she initially started with. Some students may want to rewrite and just look at the y's and say, okay, I have 5 y's, and together that makes 20. So again, using their multiplication strategies, they could say 5 times what equals 20, and that would be 4. And teachers will encourage students to go back and plug it in for each one, and we can see that each volunteer received 6 stickers, and 6 times 5 is 30. Now the last one is a little different because we have some subtraction going on here. Mia distributed another group of flyers among the 5 volunteers, but then she remembered that she needed to give some flyers out to the teachers. So she took back 2 flyers from each student. It's very similar to the one we just did. However, this time we have 5 groups of W minus 2. If she gave out some number of flyers and then took 2 of them back, her total is actually going to increase. So students might benefit from drawing this and regrouping. So instead of having it 5 groups of W minus 2 equals 40, they may benefit from rewriting it like we did the last time and grouping the W's. So we know she has this 10. It's a negative 10 because we have negative 2, negative 2, negative 2, negative 2, and negative 2, which is a negative 10. And then there's 5 W's. Okay, this may make it easier for them to see. And the total at this point is 40 before she takes back the 10. So if she takes back the 10, she's actually increasing her initial total to 50. And this is where we get into talking about the inverse operation. So when she's taking those flyers back, she's actually increasing her total. So when we're redrawing the last step, the 5 W's are going to equal 50, not 40. Okay, so now we have, again, I'm going to rewrite it so that way we can see it both ways. So this would be the other way they could write it, 5 of something minus 10 is equal to 40. They can look and say, okay, I have 5 of something, and that is equal to 50. 5 of something is equal to 50. And then they would say, oh, 10, because 5 times 10 is 50. So then we would know that W equals 10. And we could go right back up to the beginning and just double check our work. Now this one is a little different because it's going to be 10 minus 2 for each volunteer. So each volunteer ended up with 8 flyers, not 10. 10 minus 2. And 8 times 5 is 40. So again, tape diagrams, excellent way to help students with algebra.